So, welcome everyone to the subgroup for energy efficient HPC software. We're going to wait a bit until everyone has come over, and then I would say we make a short round of introductions so that everyone knows each other, and then go through discussions on some of the questions that we sent around in the SurveyMonkey. Yeah, so I guess then I'm simply gonna go around and start the introduction. Yelita, can you introduce yourself shortly?
Yes, hello, good afternoon, or I don't know if all of you are in the same timing, maybe good morning for some of you. My name is Julita Corbalan. I'm from the Barcelona Supercomputing Center, and I'm also the CTO for the Energy Aware Solutions company, and I am working on the Energy Aware runtime software. And this session, it's of course is the most interesting from my side. So the software, I don't know if you know it, but it's for energy monitoring and optimization in HPC data centers.
Thanks. Ietsu Kodama.
Hi, my name is Ietsu Kodama from Riken in Japan, and I developed the FUNAC supercomputer and the power control mechanism, such as the echo mode and the core retention is applied. And I currently evaluated such power knob evaluation.
Okay, thanks. Thorsten.
Yeah, I'm Thorsten Wyatt, and I'm with Hewlett Packard Enterprise, and I'm a software architect working on power and energy management of our HPC systems.
Daniel Wilson.
Hi, Daniel. I'm a student at Boston University, working on a PhD in computer engineering, and currently also interning with Intel on the team that's working on GOPM. I'm really interested in being a part of sustainable computing, and I think one of the ways that I hope I can contribute toward that is in energy aware and application aware optimization through software.
Great, welcome. Sid?
Sirjana, Intel, working on some on GOPM, the open source software solution that was alluded to before, and also representing as an active participant of the Power Stack Consortium, a community-wide collaboration that also works towards software-driven energy efficiency solutions. Thanks.
Thomas Ilche.
Hello, Thomas Ilche from TU Dresden. I'm mainly actually into measurement, but I also work on the run rules for the Green 500 submission, and so I'm dabbling a little bit more into metrics for energy efficiency and like how to evaluate energy efficiency of software.
Thanks. James Lavis. Okay.
Looks
James
like you're on mute, Jim.
He just mentioned that he's going to listen and not be able to speak. Yeah, then we're going to go on to Steve Martin.
Steve Martin, HPE, firmware architect, and have been kind of working with the different teams on Power API, Power Stack, other EEHPC working groups. Thanks.
And then Yanis.
Hi, I'm Yanis, AMD Research. I'm looking into heterogeneous computing fusing GPUs and FPGAs. Anything from like programming models, runtime systems, and anything in between.
Okay, thanks. And I'm Matthias Maiterth from the Technical University of Munich, and I worked with the GOPM team and did my PhD in reference model for integrated energy and power management. So very much interested in the topic as well. Okay, that's for the introductions. We sent out SurveyMonkey on questions regarding energy efficient software and how we actually can improve the cooperation between different software systems and how to actually get the interest and have HPC centers run energy efficient software and get more interest in that. So I collected a few questions, and with you answering, we kind of sorted them to interest. And I'm simply going to read them out, and then we can start discussing them. So the highest interest was, should energy efficiency be in scope of the user, or is this a systems problem? And the user should have to care only about performance. This is going to be an interesting discussion just after. Then, do you see enough interaction and sharing of information between system software, or different system software systems that are present in the same facility, and are current API sufficient? So we already heard from a few people that invested in some of the APIs. Is this enough? Where do we need to go in that direction? Then the next question is, which components of the HPC software stack have the greatest impact on overall energy efficiency? So we can there go really into what do we need to care about, or which software systems perhaps are underrepresented in the current considerations. And then asking you again directly, who do you actually need to support your endeavors in energy efficient software in HPC? And can you convince them by giving them the right numbers? Do we measure the right things? And do we actually have access to this to convince the right people in the right places? And then, since it's an energy efficient HPC working group meeting, this forum really provides space to collaborate. And what are the things where eHPC working group could support you or us in a way to start new initiatives or actually improve the endeavor of energy efficient software? So with that, I would go to the first question. I want to spend around not quite 10 minutes on these and simply go through with the discussion. So regarding scope, is energy efficient software a user scope thing? Should this be more system software, be hidden away? What is your respective stances on that? Any ideas or comments?
Hello, it's Julita here. Can give you my feelings just to start.
Yes.
The contribution. So I think the user, well, my feeling is that we don't have to force to select one option or the other. Of course, for the users, typically they are more concerned or they take care of the performance. That's normal because for the site is the most important. But I think the tools, the different tools that there are, can offer different levels of user implication depending on the profile of the user. So there are a lot of users, even a lot of them, they are not in the context of computer science, so probably we cannot ask them, even if not being aware of too much of the performance or not taking care too much even in performance. But for those users and those data centers that they are more interested on optimizing the applications from an energy efficient point of view, I think it's okay that there are some tools, not all of them. I mean, my feeling is that we have to be as much automatic as possible and not ask for any user intervention. But I think it's okay, and it's a good idea to have some tools that provides this option to work based on user hints to take more profit, no? But because there are many different user profiles. So My point is that we don't have to, or I think we don't have to force to be one way or the other.
So if users do not actively use that, should they then be incentivized, or should it simply be hidden away? And if the need arises, they're going to come to the tools that we actually are working on.
Sorry, can you repeat the question, please?
So when some users that are not interested in the kind of software targeting energy efficiency, should that then automatically be handled for them, or how do we get them to either the interest of using them, or don't they have to care because system software is good enough?
This is what I think. I mean, if the user is not interested, or the user doesn't know how to do it, because probably there are the two types, no? Some users that doesn't have the skills or the knowledge to do it, and maybe other users that don't care about energy. But of course, energy is also a topic for the data center. It's not only depending on the user if he wants to be energy efficient or not. So I think there should be some solutions, some tools that do it automatically without any user intervention. But I also think, as I said, that I think it's a good idea and a good option to have some tools that accepts hints and information from the application developers to be more energy efficient with these hints. But I think the automatic solution should be also there, because there is a significant percentage of users that or either don't want to do any change or any effort, or they don't know how to do it because they don't have the skills and the knowledge to do it. So the two options, I think they can coexist, no? Yeah. So I think it makes sense to have the two options.
Any other views where they see both of the options coexisting actually conflicting?
Well, coexisting doesn't mean that you have to run the two things at the same time, or the two different solutions. So it could be the same solution offering two ways to work. That's possible. So one solution or one tool that supports both being completely automatic and some hints, or it could be different solutions. Some automatic thing, some automatic tool, and one option or one tool that is explicitly loaded by the users. So it will be the ideal situation if the two options can coexist, and that could be provided by the same tool, or synchronizing different or coordinating different tools. Probably at this point that is a little bit complicated, no? But why not? But I am not saying that all the options and all the alternatives should be available at the same time. Probably this is quite complicated, no? But it's like when a user is using profiling tools, for example, no? They can use explicitly some profiling tools. So there can also be some energy optimization tools that can be explicitly requested by the users for those users that are more energy aware, no? More experts, no? Providing hints or optimizing the applications. And for those users that don't want or don't know how to do it, there can be some automatic solution in the system.
How do others?
So actually, I agree with that. So I think also it's not either. It's together most likely. What I'm seeing is, I mean, so I remember what yesterday some of the talks discussed, which was like that the most improvement in energy efficiency came from new algorithms used to solve the same problem. And I think there is where we have to think about that we can do a lot on the system level. As a system provider, that's what we focus on. But at the end, it seems very limited in terms of improvement when we look at what an application could improve if it actually changes how it works. And I'm not sure how we engage that community really to look into what they are doing to, just improve the algorithms they are using.
So for the scope of this breakout session, are we limiting ourselves to just discussing optimization algorithms and efficiency for individual application jobs? Or are we also including in the discussion broader system level software that interacts potentially with these job level, finer granular entities?
So the target is really the broad scope of software interacting with energy and power. So operating systems, software interfaces, system software, tools, applications, anything on there, anything that is inside of the scope, however, not necessarily infrastructure. Even if we have the APIs and the interfaces, interfacing with the infrastructure might be useful to optimize some of these. So, yeah.
Okay, thanks. Yeah, and I agree with both comments, Julita's and Torsten's. So really, if we are talking about all sorts of software, I think we are all in agreement, right? That we will need to have every HPC facility will have to account for two different classes of software. One is software components that rely on hardware protection, system protection, that something perhaps that the system administrators would find it more useful, something to enforce not just hardware protection, but also site level policies, right? Things like capping the power consumed by each rack, for example, right? And then there is the other class of system software components that perhaps either individual application programmers or individual power researchers would want to use in order to optimize their own software within the confines of the site level policies, right? So within their constraints. So we do see, in my experience, I've seen two different such classes of software components. What also, I guess, comes hand in hand with these different classes of users is the extent of security and access permissions that we grant to these different classes of software, right? So one is software components always intended to be run in privileged space, and you need root permissions, and almost always the end user is going to be the system administrators. But then we also see, like application level software components where on one hand, we do want to give these power researchers the capability of, doing system power capping and frequency fine tuning and whatnot. But we do have to, there is this constant challenge where the site needs to be aware of what kind of privileged knobs are these fine-grained software components accessing, right? And there needs to be this kind of consensus between the software vendor, the vendor who is providing this fine-grained, software component, and the facility. There needs to be a consensus between them about how do you manage the security permissions, and do you perhaps label your users into a privileged group where only a certain set of users get to run this software just because you're tinkering with these privileged access knobs? Or does the facility classify certain knobs to be really safe and user accessible and therefore can be controlled and monitored by any end user, right? So with that I'll shut up a bit, but just wanted to point out the security angle and there's two classification of two different types of users. Okay.
So that's actually a good point. I just wanted to put the devil's advocate. What if we don't have a benevolent user, but somebody that actually might behave different than a sysadmin that tries to keep the maximum power draw in check? So I think me and Torsten had long discussions about exactly this aspect of what can I do if I actually want to overrule a decision by a user that is not running their job as I wanted. So any thoughts on that?
It seems like there's this range of different layers of control and visibility that are needed here. Like, we want the user to be able to control things so that they can actually take those really big savings opportunities that were discussed yesterday at the application level. And in order to actually make informed decisions about how they're going to be changing their application or controlling their application, they also need to have some visibility. Of course, visibility of whatever's happening on the system might be in competition with security objectives. So in addition to the user's own visibility, there needs to be both control and visibility at the system level, at the administration level, something where they can use their own visibility to do, say, like automated anomaly detection or detecting other types of problems, and then also have their own control overrides so that if problems are detected, they can actually resolve them. So it seems like there needs to be, basically we do need both if we want to be able to achieve the most types of savings, but if we still want to be able to actually keep our system running safely.
I want to pick up that, since we are just at the 10-minute for one question, and move that over to the, if we now have a user that is knows what they're doing, either developing an application or system software, the question was, who do you need to support your energy efficiency endeavors in software, and can you convince them providing the necessary numbers? So do we currently have the metrics collected? Do users have the access so that they can actually show that they're a user that is optimizing the application for energy efficiency, for example? Can we convince the right people using these numbers to actually help us in developing energy efficient tools, applications, system software, and so on? Any thoughts on the metric collection and these issues?
I think we have the metrics. I mean, there are metrics collected automatically by system monitoring tools like DCDB, or DCDB is the one that I know a little bit more, but for example, there is also Examon or other tools doing intensively monitoring, collecting metrics, but also the tools like, for example, we in ER, we also report metrics from the applications to our database. So I think we have the tools to report the metrics and to correlate with the job IDs, for example, to the users. So from my experience, I think we have that metrics. I don't know how easy are with all the tools to later get or analyze the metrics, but sometimes if the information is in the database, which is the most relevant, later is more a matter of creating some commands or to making easy the access to this information. But I think the information is there. There are some independent tools for monitoring and also some other tools. I don't know exactly, for example, the reporting that GOPM is doing right now, but at least for ER, I know that we are reporting all the metrics.
So I am sure that everyone agrees that we have the tools and it's recorded. For me, as I see it, this information is often stored in a database and then perhaps analyzed, I don't know, a year later, when the project that actually started this collection of data is then coming to a point where, yeah, either the project is almost over and one needs to get a report, or when somebody actually says, hey, how can we use this data? But has anyone actually seen how that is used in centers, either approaching people saying, hey, we could actually improve the energy efficiency of a specific application, or somebody going out to some of the data metrics collection and using that to make the point about why we should use specific optimization or not? Has anyone seen something like that out in the wild, or can make a point for or against?
Yeah, definitely. Sorry, go ahead, Ken.
So in the cases that I've tried at collaborating with university lab and with the U.S. national lab, in both cases, it seemed to be very much trust-based. Like you can get that information if you're a trusted researcher or part of a trusted research group, but it's not typically a thing that's offered to common users. So I think that seems to be something that, at least in those 2 data centers that I have worked with, is not something that's going to be as easy just to say, like, if you're an ordinary user who wants to try and optimize your own personal applications for energy efficiency, it will probably be a bit more difficult to get into that.
Sid, any comment on that? You wanted to chime in as well?
Oh, no, well put, Daniel. No challenges there. That comment definitely applies to applications and no. So that type of data where we need essentially only preferred set of researchers would benefit from it. I believe we are talking about the type of data which is more long running, perhaps not just limited to a single application, but the data that represents the behavior of, say, a node or a group of nodes over a long period of time as applications come and go, right? So that is, again, that class of data. And then there is the class of data where you're just limiting yourself to the application behavior, which is perhaps more accessible. It should be okay for the facilities to make that more accessible, right? So to the earlier point, that if we have software that is just profiling and monitoring applications, facilities should perhaps provide databases and mechanisms to access the individual reports and trace files of those individual applications to their respective developers. But when it comes to long-term system health or system safety or system behavior type data, that is when we limit that data accessibility to a privileged set of researchers, right? So I think I would like to hear from other facility members in this forum, though, specifically those representing system integrator companies or those representing the facilities themselves. Do you see such long-term this type that class of data, right, where you store data for a long term? It's not a representative of a single application, but the behavior of the health of the system and the life cycle of the system. How often do you see system administrators dig into that kind of application? And do you really see that kind of data being used for taking instantaneous decisions like power capping certain racks? Do you see that type of data being used during discussions with the utilities companies, right, to essentially argue in favor of or against a certain policy? Any input on that front?
I'll bite a little bit here. So back to the other question of what data is available and whether it's available to actual application developers and stuff. I think there is, in some cases, a interesting problem here, because even though, an application, someone running an application, either the app developer or the end user of the application, should have ability to see their own data. The mechanisms and APIs to get them that data in a way that doesn't have perceived security problems is somehow, that data, the APIs and stuff need to be provisioned to allow them to get at the data, and in a way that's clear that they're not accessing data that they shouldn't. So I think that's one aspect of making it available, is sometimes it gets maybe caught up in the red tape. Because if all of the data is in a large database and it's hard for, say, the administrators to separate the data they should and shouldn't have access to, that can be a problem. I don't have as much experience working with the site teams on individual when the sites are doing negotiations and stuff. My feeling, I think the understanding that I've typically worked under is that the sites own the data. the vendor doesn't own the data. The vendor facilitates subsystems and maybe provides the hardware in order and the APIs mechanisms to collect and store the data, but the data belongs to the data center or the customer that owns the system. I'll go on mute.
That was a good point about a lot of this data, even though available, is sometimes behind the fence where it first has to get out with a lot of procedures and actually dividing the data up. But going to the APIs and mentioning that the APIs themselves have to be vetted, that there's not any security issue, and then obviously the data sharing issue, who actually gets access to what and sees what. Often there's also, if you have the data associated with actually usernames, let alone to think of all the data privacy issues that centers could get into there. So completely different rabbit hole. But regarding the APIs, since we have and see more and more system software in the centers that actually care about energy efficiency, and we do have some APIs that collect, now the next question that I want to go to, and I think within the time we're actually good going to that, the question is, do you see enough interaction and sharing of information between the software components in the system? So yeah, from APIs that are present and exposed from facilities or like the CPU performance counters, to when system software is using that and then hands that over to example the scheduler. So are the current APIs there sufficient for that information? And what's your stance on sharing of that information between different system software? Any thoughts?
It's just one thought that I have is about just challenges related to sharing up versus sharing down in, say, like some kind of power stack. I think there are different challenges between, it's easy enough to say, given that API discussion we were having, like if you do have access control over data, to say, okay, I'm allowed to access the power information from this server because this is where I was executing my own jobs. But what about, say, the other server in the data center that's hosting all of my storage? And it just so happens that server is also hosting a lot of other people's storage. Do I care about the power information for like how my job is impacting power consumption of that other shared component? Do I care about how much influence my work is having on the site level cooling facilities in aggregate? If you do care about those, it's going to be a lot more difficult to do some kind of justification of access to that data, since it is going to definitely be influenced by not only your stuff, but other stuff executing in the server. So I think one of the, maybe a related question I would have for practitioners is, like in data centers, is do you have anything like this, like ways to share information down a power stack so that somebody executing on say a server or a few servers can understand what influence they're having across the data center?
Well, I mean, there might be certain shared resources where the data is perhaps more accessible than the others. For example, I'm thinking of network fabric, right? If you do treat network fabric as a shared resource, at least the switches are, right? And if you do consider their activity to be meaningful enough to give insights into perhaps what's happening in different parts of the systems, access to data from a fabric manager, for example, right? The centralized server running that keeps track of all the shared network resources. Access to data from such servers would be meaningful in, I guess, predicting the usability of the different components of the system. Now you could track that to energy or power, or perhaps you cannot, given that the contribution of network is still pretty low as compared to compute power, right? But that type of access is what comes to mind in terms of shared resources. Did you have some
following on that is for network resources, I often do not see what my contribution to the total load is, or if I'm actually impacted by another job communicating, because I'm nodes, I allocate a node for a job or several nodes and are distributed across the server hall, and I actually do not necessarily know which switches I share with other jobs. So for energy, I think that's the same as in for the cooling. That's, again, I'm not sure who else is impacting that a specific cooling tower is on or not, or if that is just my job. So do we have the APIs for that, or do we have the information for that? Is that shared down, Stephen?
Is the question about cooling, or
about shared resources, as in already in a non-energy and power domain, we have issues where we can't actually see all the information, right? And the contribution, kind of.
Yeah, I was going to just make a comment that, you know, back to Sid's point of how much maybe the network power consumption is in compared with, say, the CPU power consumption or GPU power consumption. And the comment I was going to make, without having data to back it up, is that I suspect that communications patterns, when you have, say, large jobs running, large multi-node jobs running, and maybe communications, you know, the application communications being interfered with by maybe another job that's doing a lot of bulk IO transfers. The actual slowdown of the application and making, you know, some other application run longer may be a much larger impact on actual energy to solution than the energy used by the switches or NICs themselves. That is, and I don't know that there are necessarily, that's a difficult problem. I know people do studies where they'll run certain applications on a large system in isolation and then run it again with an aggressor application that sets up maybe the conflict in order to measure, you know, how much contention there is and how much that contention contributes to job slowdown. But I don't know that there are any currently tools that allow you on a say a large system with a mixed workload to quantify those kind of things, you know, without doing controlled experiments. But I'd be interested if somebody else had knowledge in that area that they wanted to share.
Any direct responses? Very good point.
Yeah, I'd like to hear perhaps from like Kodama-san, Yotsu Kodama-san, if you have any input on this to Steve's question, right, about perhaps benefits of large bulk storage operations or IO operations and opportunities to monitor those.
So in the Fugaku case, the power consumption is reported in each jobs for users. And also any information about the file access or something is also. But from the ordinary user, it is not interested in that power efficiency because that is no incentive to that reduce that power. So power efficiency is only currently only issues for that operation manager or development of the large supercomputers. But in our in the Fugak case, currently that is only that the node our product is that the accounting, but we will plan to that the accounting to the power consumption. So if we using that the accounting of the power consumption, then user will also that the interested in that the power consumption, I think. So that is very, but currently not yet interested in each users.
Thank you.
Mm-hmm. Yeah, that's actually kind of a big contrast to the statement from Yolita in the beginning, as in users should have control, but then only a few of the users, most likely energy and power researchers, want a direct access, and for the others we actually have to have an incentive. So scheduling on node hours and on power, that has been in discussions for a long time, but I think there's no center that has currently really followed through with that. I want to move on to the next question that was stated, and perhaps we're going to get into interesting discussions again there as well, with which is which components of HPC software stack. We already mentioned something like a communicating software and software stack for energy and power. So which component of the HPC software stack have the greatest impact on overall energy? With the statement of Steve Martin, that would actually be not necessarily software that controls energy and power might have that impact, but actually other applications stalling something because of I/O access or network access. So what are your thoughts on that? Did you do any experiments in that regard, or where do you see we can actually make largest impact with software?
Could you please clarify the question? Is the question that out of all the software entities running on a system, which software consumes the most energy and power?
Not only consumes the most, but where would the starting point, where can we impact the consumption most? As in, where can we steer it most and direct it most? As in, still with the goal, obviously the goal is to actually run the application, right? Or the user application.
Isn't the answer just the application itself? So if we have an HPL benchmark running, that will be the application that will contribute more to energy and power, and perhaps that's the point where we should optimize for?
Yeah, but I'm okay, agreed, if we have a constant workload. So might that be actually the scheduler placing the nodes, the operating system selecting the frequencies, what is the interaction, and where does each of you see where most impact can be made by having software not just tuning for performance, but actually looking into incentives for energy efficiency? So yeah, I don't think that there is just one answer or correct answer, since the goal itself is running actually, I don't know, for the weather simulation, for example, you can't sometimes change the code so much unless it gives you completely wrong output.
Yeah, so I would agree. I think the scheduler has a big part of it. The actual application, I think, is important, but in some cases, just the choices of libraries and algorithms that some of the applications allow for is a big deal. And potentially profiling or running some assembly jobs or whatever to figure out for a given data set or a given hardware configuration, what is the most performant or the most energy efficient, perhaps both, way of putting the building blocks together in order to get the desired outcome. So I think in almost all of the cases, it's a multi-factor kind of a question of it, is how do you use the different parts of the stack in order to achieve your objective, when there's a lot of choices and a lot of knobs that potentially can be adjusted.
Yulita, I saw you unmuting. Do you have a comment on that?
Yes. So if we were discussing, so I don't know if I completely understand the, let's say, the question, but if we were discussing about which element, let's say, in the power stack, for example, was most relevant or most important to save or to manage energy and power, okay, probably I would say it's a combination, as you were saying, of different, of course, the runtimes, for example, are really important for optimization, but the scheduler is really important, okay? Something that the specific part of the scheduler that will work as a global or an energy manager, which probably is an independent part, will be also important. But what you were saying, I think it was Steven in the comment, and I don't know if I understand well, what is really, it's very, very important is this optimal utilization of the already existing libraries and tools, and not necessarily related with an energy management tool. So I made that comment because I am always with ER doing application evaluation, application analysis, as something that for me is really, really amazing is the fact that if you miss in your configuration for your applications, or if you select the version that is not the optimal in the library, the performance of your application sometimes is multiplied by 2, sometimes by 3. And of course, this is a significant penalty in power consumption and energy management. And it's nothing to do with any tool for optimization related to power. It's the application itself. So something that is really, really important in the energy efficiency management in general, independently of the tool or independently of the component that is taking care of that, is that the applications are executed in the most efficient point of configuration. No, the libraries, the mapping, the number of processes, the number of threads. For example, the affinity, sometimes setting just the affinity mask or the right affinity configurations is a nightmare. In some clusters, it's not well configured, and that makes applications consuming, as I said, twice the execution time, which is quite stupid if you plan to do some energy optimization on the other side with a tool. So you will save much more power and energy and money if you just were running your application with the right configuration. So on one side, independently of the tools, having this optimal configuration for applications is really, really important. And then, assuming you have your optimal point, I will say that the elements in the software stack that will play a very important role is, on one side, the scheduler with the allocation of nodes, this helping in this mapping and affinity settings, and also the runtimes that can automatically optimize the library, selecting the optimal CPU frequency or GPU frequency or memory frequency. That can be guided by the hardware, of course, but I think runtimes are much better for that because they have the knowledge of the application.
That completely matches everything that I've observed as well. Sort of a question that I've wondered about it for a while, though, is like, for me, when I'm encountering these types of challenges, it's because I'm a third party. I'm trying to research energy aware computing, and I have to build up my expertise about these applications from nothing. So if you're going the other way around, if you're the application expert, the application user, how is this usually handled in a data center? Like if somebody's doing some molecular dynamics simulations, how do they figure out how to configure their tool? Do they speak to the person who developed the simulator tool, or are they expected to do this on their own, or do they collaborate with their system administrators to figure it out? Or is this a completely just open issue that there isn't really a solution for?
Any comment or clarification to that? So my comment on that would, depending on the library and the users, and also how the center supports their users. Sometimes when libraries are, or specific, I don't know, molecular dynamics applications are provided as modules, they're often pre-configured with the most performant libraries on that system. But as soon as users decide to either compile themselves and so on, or develop the applications from scratch, then they have to know themselves. So also we had the tools before. The tools normally only give you a pointer where things might go wrong, not actually how to solve them. So they don't really tell you that there's a better, I don't know, that they could use, I don't know, a better plus library and not write their own matrix multiply. So pre-configured is one thing by the centers, if the centers provide that. And for everything else, it's up to the user, unfortunately. So one takeaway is really we should educate our users well so that they're aware of this. Any comments on that?
I guess maybe just another one for me on that last note about educating the users is in general, like as far as usability goes, I love it when we can do things that just automatically solve the problems for the users. I mean, that's part of why I'm interested in being in this energy aware, runtime kind of problem space. But sometimes it's not always able to be done automatically in an effective way. So where do you find the balance between trying to educate the user about types of problems they can encounter versus trying to fix them automatically?
And maybe I'll make a comment here. Is this so do the sites have centers of excellence or kind of admin groups or whatever, support groups maybe is the right word, to help connect the people doing energy research and energy efficiency research with either the application teams or the users? Is that a common practice at people's sites on this call?
On that, I can comment that only one of the centers had real user groups meeting every week, and that was mostly on performance issues, and system tool developers were often not in these discussions. I don't know, any comments from other sides? So since we just got the message from Natalie, I would just shortly go on to the last question that is still open to discuss. How can the EHPC working group actually help us in achieving our goals? So what are there any things that every one of you needs from the EHPC working group to enhance your goals in providing energy efficient software, and how could we start new initiatives, or what are the needed initiatives, and what are the things that we should pursue with the EHPC working group here?
Well, one of the things that I really like, I'm excited about, which is already happening within the working group, is the power measurement sub-team, right? Where challenges about measuring telemetry at scale maintaining them and leveraging them, opportunity analysis of looking at that data and actually making operational decisions about operational analytics related stuff, to decide how to better improve your system management. Topics surrounding that and having subgroups within the working group to focus on that is something I'm looking forward to. I know Thomas is running one of those subgroups. Thomas, feel free to chime in if there are opportunities there.
Yeah, I don't know. I was looking a little bit for the connection between like the benchmarking of the system and like real application energy efficiency metrics. But it's such a hard topic to tackle. I'm struggling to find a way where to start. Like when I have the goal, like could I get a number of how energy efficient did my system run in the last month from a application perspective? Like some good proxy of how much science did I get done per joule? But it's really so open-ended. I don't know. Yeah, I don't want to. I don't have the time even to go into details. Sorry about that.
So the starting of a post-mortem top 500 energy efficiency, as in after the center is shut down, collect all the data and then compare how efficient it actually run?
Yeah, I mean, like going beyond this, I mean, we can compute the traditional PoE, ToE numbers, but can we get some more numbers that are closer to related to the applications that are running? That's kind of my question. Yeah. And we could do this as postmortem, but I think it's more interesting even as a like operational question. Like you implement all these efficiency improvements. Can we have a dashboard of how energy efficient we were in the last month because our users did utilize the new libraries or something like that? Yeah.
Okay, I think we have to almost move over to the other call or to the main group. Mentioned there, we did have a dashboard group of the HPC working group, but I do not know if they actually were pursuing these efforts. I would thank everyone for participating and giving this good discussion. I hope it was also really helpful for each of you to think about some of the things. And I would say we head back to the main room. Thanks, everyone.
Thanks, Matthias, for driving this. Thank you.